Hi there, Mrs. Thompson here. Today we're going to talk about mixed naming. So what if I give you a bunch of formulas and ask you to name them, and I've mixed them up so that there's a mixture of ionic, covalent, and acidic compounds? Then it becomes really difficult. What you have to do, and we should have done this in class, make a compound naming flowchart. And what you have to do is ask yourself a series of questions. Does it start with a hydrogen? Does it start with a metal or ammonium? Or is it just a nonmetal plus a nonmetal? Okay. On this side, you have two little jokes about sodium chloride. One is sodium dragging chlorine says this is assault, like as if she's physically assaulting him. And then you have sodium and chlorine, and sodium's given her electron to chlorine, and chlorine says, you complete me. That's because, remember, it's completing its valence shell when it does that. All right. Next, we have this table, and I do want you to draw this in. We're going to compare ionic compounds, covalent compounds, and acids. So pause it, draw it. Okay, so we'll start with what it starts with. This is the clue to tell you what naming system to use. So if it starts with a metal or ammonium, that is going to be an ionic compound. If it starts with a nonmetal, and that's not ammonium or nitrogen, I would check to see it's not ammonium, then it's covalent. And if it starts with hydrogen, then it's an acid. All right, so then the next one says contains what? So it contains metals, nonmetals, or polyatomic ions. Well, ionic compounds start with a metal, so it's going to have a metal in it. And it ends with a nonmetal, so metal plus nonmetal, metals first. It also has polyatomic ions. So ionic compounds, you will find all of these: metals, nonmetals, and polyatomic ions. Covalent, just nonmetals. Okay, and then you have acids. Acids are made up of hydrogen plus something else. And so hydrogen is just a nonmetal, but it's made up of nonmetals, hydrogen plus some other nonmetal, or hydrogen plus a polyatomic ion. Next question, are charges used to figure out the formula? Okay, in ionic compounds, you have two things that are charged, two ions that are charged, and so you have to know what those charges are in order to balance out the charge in any ionic compound. That's a yes for sure. Covalent compounds, well, you are given a name that includes prefixes like carbon monoxide. I know that I have one carbon, one oxygen, so there's no need to use charges in that. For acids, you have to take hydrogen with a plus charge plus whatever the nonmetal is, or the polyatomic ion, so you definitely have to figure out charges there. Okay, next, what type of bonding occurs? Well, in an ionic compound, you have two ions coming together. That's an ionic bond that's happening. So a transfer of electrons that has to happen. In a covalent compound, you have sharing of electrons. That's a covalent bond. And for acids, you have actually it's a covalent bond because you just have nonmetals in there. And so the nonmetals are sharing, but they're sharing unequally. So we have a polar covalent bond. So polar, that's almost ionic. That's why we use the charges. They are also called, so this is a good thing to know, ionic compounds are also called formula units. And they're also called salts. So any ionic compound is a salt. It's not just sodium chloride that's a salt. It's any ionic compound. For covalent compounds, those are called molecules. For acids, and those are just called acids. And then I wrote this other part. It says, what are some common mistakes made while naming these compounds? So one is forgetting those Roman numerals for anything that has multiple charges, cations anyways. Another is changing the subscripts on the polyatomic ions. Those don't change at all. And then putting parentheses around hydroxide. You have to remember to do that. For covalent compounds, it's forgetting about the diatomic elements, so Brinkelhoff. Forgetting to use the common names. And so instead of H2O being dihydrogen monoxide, it is just water. And ammonia and ozone, those were the three. Okay. And then for acids, some common mistakes are using hydro all the time. Hydro does not mean hydrogen. It just means you have a binary acid. So only hydro on binary acids. And then forgetting to add the AQ at the end, sometimes I'm guilty of this one. Make sure you add AQ at the end because it's not really an acid unless it's dissolved in water. Okay, now we're going to do some examples. We're going to name these compounds, but before we can do that, we have to figure out whether we have an acid, a molecule, or a salt. So let's do that. First one, I'm going to figure out what does it start with. It starts with a non-metal, and that non-metal is not part of ammonium, so I have a molecule. I'm just going to write, this is a non-metal, oxygen's a non-metal, non-metal plus non-metal is a molecule. Okay, so with molecules, for my naming system, I'm using prefixes, and this is the only time I use prefixes is when I'm using molecules or naming molecules. So dinitrogen, 2 nitrogens, pentoxide, 5 oxygens. Remember that when you have an oxide, if the name or the prefix ends in an A or an O, you drop the A or the O. So this is pentoxide. Next one, it starts with a hydrogen. So anything that starts with a hydrogen is an acid, as long as it has AQ next to it, and this one does. So I'm just going to draw a line after the hydrogen so I can figure out how to name the acid. And I'm just going to write, this is hydrogen plus a polyatomic ion, makes an acid. Now if I name this, I have an oxyacid. Oxyacids are named by the polyatomic ion and then changing the name ending. So if I look up PO4 on my list, or I have it memorized, PO4 is phosphate. Okay, I'm going to change ate into ick. I ate something icky. So instead of phosphate, I'm going to write phosphoric. This is one of those that goes back to almost all of the name. This is phosphoric acid. Okay, next one we have a non-metal plus a non-metal. That is a molecule. Molecules are named using prefixes, but this is a special one. This is one of the 3 common names that you have to remember. It is ammonia. Okay, next one. Notice it has an AQ after it. And I put this here because sometimes I get the question, is everything that has an AQ next to it an acid? That's not true. Aqueous just means it's dissolved in water, and almost any salt can be dissolved in water, and so lots of salts, even and acids, have AQ next to it. And so don't assume acid. All right, so what is this? Well, potassium is a metal, and then I have hydroxide. So everything after potassium is a polyatomic ion. I just said it's hydroxide. And so metal plus polyatomic ion is an ionic salt. Okay, so let's name it. In naming ionic compounds, you just name the cation and the anion. You check to see if it's a multi-charged cation. This is potassium, it's in group 1. And so everything in group 1 is always 1 plus charge. So no multi-charge. So this is just potassium. Then I'm going to name everything after the line I just drew. That's my poly. That is OH, which is hydroxide. So this is potassium hydroxide. Next, we have PbPO4. So Pb, that's a metal. That's lead. I'm going to draw a line after the lead, and I can see that I've got more than one uppercase letter. I've got a polyatomic ion. It's a poly. Metal plus poly is an ionic salt again. So we're going to name it. This is lead, Pb. And I need to remember if lead is in a multi-charge metal or not. Well, lead is in group 1, not in group 1. It's not in group 2, and it's not in the magic triangle. It's actually one that has multiple charges. And so I need to say which lead this is. So I'm going to see, let's see. Here we have 3 of the phosphate, and I know phosphate's a -3. And if that's true, and we had 2 of the phosphates, that means all together over here, this would be a -6. And so then this would have to be a +6. Well, I have 3 leads. So in order for this to equal positive 6, this lead had to be lead 2 plus, which is lead 2. So lead 2, and then PO4 is phosphate. Next one, we have hydrogen, Se, selenium. So it's starting with hydrogen, and I know it's an acid. So hydrogen plus, now I need to figure out, is that poly or just a nonmetal? Well, that's just a nonmetal after that line. And so this is an acid. It's a binary acid because I only have 2 different types of elements on there. And so this will be hydro, and then the root word for the element, ic acid. So hydroselenic acid. All right, now we're going to take names and write formulas. So first one, hydrobromic acid. Let's see. Acid tells me it's an acid. Easy. Hydro tells me that it is a binary acid. So all I have is hydrogen plus a nonmetal. That's binary acid. And so I'll have hydrogen and bromine, since bromic is probably from bromine. And so then we put those two together. One's a 1 plus, the other's a 1 minus, so it must just be HBr. And then all you have to do is add an AQ after it. Okay, next one is carbon disulfide. The prefix kind of tells me it's a molecule, but let's check what it's made out of. You have a nonmetal with carbon and a nonmetal with sulfur. So nonmetal plus nonmetal, molecule. Okay, so then we just have to use those prefixes to figure out the formula. No charges. So there's 1 carbon and there's 2 sulfurs. So okay, next one is zinc hydroxide. Zinc is a metal. Hydroxide is one of those polyatomic ions you have to memorize. And so metal plus a polyatomic ion, that's an ionic salt. And so we need to figure out the formulas of zinc and hydroxide. Well, zinc is in the transition metals, but it is one that's in the magic triangle. It has a set charge. So it's zinc with a 2 plus charge, because it's of the 2 in the magic triangle. Hydroxide is OH minus. And so to balance out the charge, I'm going to need 2 hydroxides for every 1 zinc. So this will be zinc OH with parentheses 2. Okay, next one, nitrogen. Here we go. What is a nitrogen? It is a nonmetal plus nonmetal. Here, let me show you why that's true. This is a molecule, of course. Nitrogen is one of the 7 diatomics. And so when you see this, you're going to be tempted to just write N, nitrogen. But that's not correct. It's actually N2. So this is actually a nonmetal plus another nonmetal. It's just 2 nitrogens. Okay, potassium sulfate. Potassium's a metal. Sulfate is a polyatomic ion. If you don't have those memorized, it gets a little bit difficult. But just think, if it ends in ate and ite, then it's most definitely probably going to be a polyatomic ion. Okay, so metal plus poly is ionic. And we need to figure out what those are, so we have to figure out charges. Potassium is in group 1A. Everything in 1A is 1 plus, and then sulfate is SO4 with a 2 minus charge. And so I'm going to look at charges. I'm not looking at subscripts, just looking at charges in the upper right hand corner. I'm going to need 2 potassiums for one of those sulfates. So it's K2SO4. All right, last one, carbonic acid. It's an acid. Okay, so let's see. It does not have the prefix hydro, so it is not a binary acid. Instead, it is a oxyacid. So hydrogen plus a polyatomic ion. Okay, so let's figure that out. Here's hydrogen. Carbonic acid or carbonic acid is coming from ick, from 8. So I ate something icky, the opposite, we have to go the other way. So we need carbonate. Carbonate CO3 with a 2 minus charge. And so when we balance the charge, we'll need 2 hydrogens and 1 carbonate. And then, of course, AQ. All right, so you should be practicing some of these on your own tomorrow. Let me know if you have any questions.